All right, so this week, we're going to solve word problems. Okay, that's all we're going to do. We're going to look at word problems, probably like 3 today in class maybe, and then a couple extra ones at the end, like Mr. Roy just said. All right, so somebody remind me first, what is a system of equations versus just an equation? What's the difference? Josh? There's 2 of them. Right? Can you give me an example of a system of equations? All right, so y equals 3x plus 2. That's an equation. Can somebody give me another one to make that a system? 7 equals x plus y. Sure. So that's a system of equations. 2 equations, 2 variables. These are the kinds of problems that you're going to be set up today. You'll definitely see some like this. You'll probably see the word sum, like sum of ages or something like that. So that means add. And you'll probably see one set up like the top one as well. Okay, what were the methods that we used to solve systems last week? I think we did two methods. Shannon?
Substitution.
Okay, we did substitution. We just practiced that because that's what we're going to use here. And we did one other method. We did graphing. Okay, so graphing, not as good when you got to find decimal answers. Also, when you're working with people's ages. Okay, somebody might be 40 or 50 years old. That's a big number on a graph. Okay, so that's why this week we won't be doing any graphing. Okay, so we're going to solve systems with just substitution. Okay, the only thing that makes it a little tough is you got to figure out the equations to solve. Okay, so on every problem on the test, there'll be 4 parts to it. The first part is set up your first equation, set up your second equation, solve for the first person's age, solve for the second person's age. So that's how each question will be graded. So just because you get part of it wrong doesn't mean you're going to get the whole thing wrong. All right, so we got a couple examples. Okay? What we want to look at representing is, how do you represent someone's age now? How would you represent it in the future? And then how would you represent it in the past? All right, so we're going to let T equal Tim's age now. So we're going to write an expression that represents Tim's age 6 years from now. This is not on your reference sheet. But how would you represent how old Tim will be in 6 years? T plus what? That's it. To find Tim's age 6 years from now, just add 6. Okay, so when you're dealing with ages in the future, you add a number because they're older. Okay, so that's an expression that represents his age 6 years from now.
If you did 6 plus t, you're not wrong. But for these, try to put the variable first. Just be consistent with that. It makes it a little bit easier to follow.
How about Tim's age 4 years ago? So this is 4 years in the past. Kaylee? Yeah, it would be t minus 4. Right? So when we deal with a problem that represents somebody's age in the past, that's what you would have to write down. That would be the first step. All right, I think we got another one of those. If R is how old Ryan is now, how old will Ryan be in 4 years? Yeah, R plus 4. That represents Ryan's age 4 years from now. How about...
We don't know how old he is, but we know we can represent it that way. If it's 4 years from now, it's whatever the person's name you're talking about, plus something.
And how about how old was Ryan 8 years ago? Yeah? Yeah, it would be R minus 8. All right, do I have... all right, yeah, let's try this one. This one a little harder. I want to know how I would represent twice Ryan's age 7 years from now. So what part of that do you think you start with? Twice Ryan's age or 7 years from now? Kyle? The twice part? Nope.
Oh, guys, think about it this way, is there something on it that's, like, you've done already that's kind of familiar to you?
Oh, Mr.
What is it?
Would be R plus 7.
Yeah, start with that.
That's because, I mean, we've done that before. Ryan's age 7 years from now, Ryan's age 2 years ago, we've done all that.
And now, whenever you have the person's age and you have to do something to it, put it in parentheses. What are we doing to Ryan's age 7 years from now? By what? 2. So this represents twice Ryan's age 7 years from now. Okay? So just get in the habit, whenever you write someone's age, we'll put it in parentheses, just in case we have to do something else to it. All right? And how about 4 times Ryan's age 3 years ago? Okay, what part do you think you would start with? Ashley? Okay, how would you write Ryan's age minus 3 years ago? Go ahead, just say that part. Yeah, just R minus 3. And what should I do with that? Yeah. And put times 4. So this represents Ryan's age 3 years ago times 4. So 4 times Ryan's age 3 years ago. Now, if I said to you, this was equal to 10, then you could solve it. If I could say Ryan's age 3 years ago times 4 was 10 years old, you could figure out how old Ryan is now. Okay, the other thing, when you're solving for somebody's age, you're always going to get a nice answer. You're not going to get somebody like 6.2 years old. Okay, every answer is going to come out without a decimal. That's one reason we chose these kinds of word problems this week. Okay, so no decimals. And what other kind of numbers would you never get for someone's age? Fraction, same thing, decimals. What other kind of numbers? Negatives. Okay, you should never get a negative for someone's age. All right, so Mr. Roy is going to show you how to go through this template, which is going to be on the test. So you can use this template to help you with every problem.
Hey guys, we might see one tomorrow where there might be like a little added box down here, all right? But this is what if we do any more we've done word problems already. We did like one last week. There was one on the test, but we didn't do it like just word problems. This week we'll just do it like the next couple days. Wednesday we're doing today and Wednesday we're just doing word problems. That's it. All right. So on your guided notes, you see this example, right? Then you see some arrows sort of pointing all over the place. What we're going to do is we're going to fill in. We're going to have little notes on here, or little hints as to what you're putting in what box. All right? So I look at this this arrow right here near name. What do you think I'm going to put there? Yeah, the name. All right? I'm going to write in the names. Write in names. All I'm going to do in this first column or row is just write in the people's names that are in the problem. That's all I need to do in that first row. Just write in the people's names from the problem. Very simple. So while you guys are finishing writing that, I'm just going to read it. Paul is 3 times as old as Kathy. In 8 years, he will be twice as old as she will be. Jordy, what's one of the names I'm going to write in? Paul. Paul. Here's my name column. I'm going to write Paul. Bay, what's the other name? Kathy. That's all I'm going to do is write in Kathy. That's all I need to do. All right? So not too bad yet. I'm going to look at this next. All right? This arrow here where it says single variable. All right? And I'm going to use the first letter, all right, from each name as the single variable. Every time, whether it's Brent, Tim, John, Linda, Dan, doesn't matter, all right? You're going to use whatever the first letter of that person's first name is, all right? You're going to use that as your single variable, all right?
But it could have like say first.
You might change, you could put something else, you could use X and Y if you want to. We're probably not gonna give you, Vanessa, we're probably not gonna give you any problems with both people's names now with that same
Like
thing.
Bill and Bob.
Yeah, we wouldn't do that, all
The
right?
only other thing you have to be careful is like, you got a problem that said like, a grandfather is twice
Yeah.
as old as his granddaughter. Those both begin with G, so maybe you want to use F for father, G for daughter. Kind of know
All right, or like, say if it was like, if it was like Linda or something like that, you might wanna use like a little, make your L like this, so it doesn't look like a one, things like that. So, how would I represent Paul? Yeah, just P, right? I'm gonna do it as a lowercase, I'm not gonna do it as an uppercase. And then what about Kathy? C. When I'm looking in this column, this first row or first column is always going to be dealing with the present. All right? This is going to be dealing with the present. So, we're representing Paul, we don't know his age. We're representing Paul in the present as P. We're representing Kathy in the present as C. All right? Usually, all right, it's going to be that first sentence that's going to talk about the first sentence in the problem, that's going to talk about the present. So let's go down here to this bottom, on the first one on the bottom, the first arrow, all right? All right, so the information to set up this equation, right? This is, I'm going to set up an equation here in this box. The information to set up that equation is going to come from the first sentence, all right? And as I'm reading that sentence, wherever I see Paul's name, I'm going to represent it as a P. Wherever I see Kathy's name, I'm going to represent it as a C. All right, well, like I said, usually the first sentence usually is going to be dealing with the present. So that's how Paul is P, Kathy's C. All right? The only time that'd be a little bit, one little note I want you to put on here. If it's a sum, all right, a sum of their ages, I'm going to have to rearrange. What does sum mean? What math operation? Anybody tell me? Josh? Good. So underneath sum, I'm just going to put a little plus. Not my best plus sign, but. So if it's a sum of their ages, you're going to take both, you would take both variables and just add them together. So it'd be like a variable, I'll put a little blank. Blank plus blank equals a number. All right? So if it says sum of their ages, I'm going to have to, for substitution, the goal is I want to get one of the variables by itself, so I want to get it isolated so I can plug it in. most of the time, we're not gonna have to rearrange. The only time we'll have to, if in the problem, it mentions the sum of their ages. Then you do whatever. If it said sum of their ages for this problem, it'd be like P plus C equals whatever it says the sum of their ages is. But in this problem, in this case, it doesn't say that. All right? Good with this. I'm just gonna scroll back up a little bit. So I'm only worried about this first sentence. This one right here. And that's going to give me what I need to fill this in. What's the first thing in that first sentence? What's the first thing mentioned? What's the first thing mentioned in that first sentence that I circled? Nini? Yeah, whose name? And we're talking about the present, right? So use the information in this row. So Paul's first, right? What am I going to put? P. P is going to go inside the circle. We'll show you what that means in a second. All right? Now, what it says is, right? What does is mean? We already have it, don't we? We already have the equal sign there all set to go. 3 times. What do I have to put? What number do I need? 3. I can put it outside the parentheses, I can put it inside the parentheses. It doesn't wear. If you guys want to, we'll put it inside. A 3. 3 times as old as Kathy. Put a C. That's it. Right? I'm only worried about that first sentence. That first sentence is going to give me the information I need to set up my first equation. It's a system, right? So I need 2. Paul, right? Paul is P. There we go. Is equals. The number 3 I put, and then Kathy, for the first equation, is just C, so I'm going to put that there. Not too bad. Now this one gets a little bit trickier. All right? So now we got to change that single variable a little bit. So we're going to still have our single variable. If it's said in the problem, in a number of years, what math operation do I do if it's in a certain number of years? What will be happening? Will it be increasing or decreasing? Increasing, right? So if I'm doing this, I'm going to add. Because it says in the problem, in a certain amount of years, all right, I'm going to add. If it says 5 years ago, 20 years ago, what am I going to do? What operation? Subtract. So in the first column is always going to be for the present. In the second row or second column, it's either going to be in the past or in the future, depending on what phrase it gives you in that sentence. All right? It could be the past or the future, either or. All right? So, in this problem, now usually the information, I want to scroll down just a little bit, guys. So I'm not going to go there yet. Let's go back up. The first sentence is usually the present. Now, the past or the future is usually going to be that second sentence. What does that second sentence start with? What does that second sentence start with? What's it say? In 8 years. What does that mean? Based on what we wrote here? Am I adding or subtracting? Adding how much? Add 8. So, whatever it says, if it says in 8 years, we put plus 8. If it said in 5 years, we put plus 5. If it said 20 years ago, then we put minus 20 at the top of the row. All right? So now I'm going to take my single variable that's here. I'm going to bring it over here. And I'm going to write plus 8 next to it. or whatever, minus 20, depending on what phrase is in this, in that problem. Same thing for Kathy, C plus 8. So just like when we did, we set up here for the present. Wherever I see Paul in the second sentence, that's how we're representing him now. Because Paul's mentioned in that second, or he, I'm representing him as P plus 8 now, because we're representing him in the future. Same thing with Kathy, or she, or her. Where I see her name in the second sentence, I'm going to represent it as C plus 8. Just like we did here. In the future, Paul was P, Kathy was C. Now we're in the future. Paul's going to be P plus 8, Kathy's going to be C plus 8. All right? So just like we put over here, information, that comes from that second sentence. Just like I mentioned a couple times, wherever we see Paul or him or he, we're representing him as P plus 8. Wherever I see Kathy or her or she in this problem, I'm going to represent her as C plus 8. Whatever equation you're setting up here, wherever you see the people's names, all right, you want to represent them with this. So you're always going to take that single variable and add or subtract a number to it, depending on what phrase it gives you in a sentence. If it's in a certain amount of years or a certain amount of years ago. All right? So I'm going to take that single variable and put something with either plus or minus. Like I said, depending on what it says in the problem. And like I said, so wherever we see those names, all right, we want to put our labels. All right, so now we're dealing with Paul and Kathy in the future. All right, Paul and Kathy in the future. I'm going to go up a little bit. So, in 8 years, we already got that covered. We don't have to worry about that anymore. We got it here. That's fine. We already did it. The P plus 8, the C plus 8. He, Mr. Hager already put it up there. Paul. How am I representing Paul in the future? How am I representing Paul in the future? P plus 8. So Paul now, this equation is P plus 8. What's the next phrase on there? Mr. Hager's going to highlight it for us. What's the next phrase on there that will help us? Will be. Who said that? Jordy, do you remember what will be, what math operation? What's that?
Equal, right?
Equals good, right? Is, was, will be. All mean equal. So P plus 8 equals. What's the next one on there? What should I put? A 2. Should I put anything else? Think I might need anything else? I think I might start a parenthesis. So it's twice we got as old as she will be. Liam?
Put C plus 8 in parentheses.
C plus 8, because she is Kathy. Kathy in the future we're representing as C plus 8. So now, I have both equations set up. All right? Can somebody tell me my first equation? The equation I use to represent them in the present. Kathy and Paul in the present. Josh? P equals 3C. Bingo. What's my second equation? Because it's a system, so I need more than one. What's my second one? Meaning? Excellent. Now, today, Wednesday, on the test, you're going to have the directions. It's going to say, work area to solve using substitution. So it says, I want to use my row 2 equation. I'm going to use the stuff that's in parentheses in the first equation, or row 1, and whatever has a, see how the P has a circle around it? Wherever I see this letter that's circled in the other equation, I want to put what's inside the parentheses. So wherever I see, whatever letter I put in the circle, I want to plug in what's in the parentheses for that letter in the other equation. All right, so I'm always going to be using the row, I'm always going to substitute the row 1 equation into the row 2 equation. I'm always going to take this here and plug it in for this over here. All right? So, what letter am I going to be substituting for? What letter am I substituting for? It's the letter that's circled. Right? P. The letter that's circled is always the letter I'm going to be substituting for. So, this 3C is going to take the place of this letter in the other equation. All right? So where do I see P in the other equation? In the row number 2 equation. Where do I see it? Actually, right at the beginning, right? Here's my P right here. I'm going to circle it. What's taking the place of P? 3C. So I'm going to start this equation with, well, actually, I'll write it out so you guys can see. Here's the row 2 equation. Right? I'm substituting for this. I'm substituting for P. Ask you what's taking the place of P again? 3C. I'll write it in a different color so you guys can see. 3C. That's taking the place of P. Everything else stays the same. Plus 8 equals 2, C plus 8. How do I know I substituted? How do I know I did my substitution correctly? How do I know I plugged the right thing in? Anybody know? Because there's only one variable. There's only a C. I can't solve there's a C and a P. It's not going to work. All right, I can only solve if there's one variable only. All right? Now, we're at what we did last week. We did my substitution. All right? I'm going to, first thing I'll do, distribute. What am I distributing? Somebody tell me, what am I distributing? Ashley? The 2 into what? What math operation? Multiplication. All right? Everything else will come down. 3C plus 8 equals 2 times C will be what? 2C. What else am I multiplying? By what number? What do I get? Positive 16. So I distributed just like I did last week. Next thing I want to do, I guess I'll say match up. Next thing I want to do is I want to move my smaller variable. All right? So I have 2 variables in this problem, right? One on each side. What's one of the variables I have? What's one of the variables I have on the left-hand side? 3C is one of them, right? What's my other variable? 2C. Which one is smaller? The 2, right? That's the one I want to move. What operation do I have to use to move it? Here's my 2C right here, right? What operation do I have to use to move it? Subtraction, because it's positive. Minus 2C. Where else do I minus 2C? From the 3C. I got to match them up. I can't minus from 8. They're not the same. All right? I don't want to move the 8. I don't want to move that either. All right? So this is what I want to move the smaller one because I won't be dealing with negatives. All right? I want to move the smaller one so I'm not dealing with negatives. This will cancel. All right? 3C minus 2C? That's the C. You can put 1C or C. It doesn't matter. Plus 8 equals 16. Now I'm going to isolate. Isolate the variable. What's my variable? What's my variable? C, right? This so happens in this problem that there's nothing attached to it. All right? So I want to isolate that. What does that mean, isolate it? Someone tell me.
Make it by itself.
Get it by itself, right? So what don't I want to move? What's one thing for sure I don't want to move? Don't move the variable. That's what that means. Don't move that. Move what's on the same side with it. Nini?
Subtract 8.
Subtract 8, right? Minus 8. What else do I minus 8, Nini? 16. Good. C equals 8. 16 minus 8 is 8. I don't have to do the last step here, but what is my last step normally?
Divide.
I would divide. How come I don't have to divide here? Yeah, there's no number what to see. I mean, I know some of you guys, you may have 1C and divide by 1 and divide by 1. You're still going to get the same answer. That's done. All right? This side's done. Whose age did I just solve? I'm not. So I got C equals 8. Now,
Kathy.
the letter that I just solved for, all right, I'm going to substitute the letter I solved for into the row 1 equation. All right? Here's my row 1 equation, right? Right here. So what was my row 1 equation? What was my row 1 equation? P equals 3C. Right? That's my row 1 equation. I just wrote it down here. It says substitute. All right, I'm going to substitute the letter I just solved for. What letter did I solve for? I just solved for C, right? Here it is. So what's this equation going to look like now? P equals 3 times what? 8. 3 times 8? 24. Give me the ages. Give me the ages.
Oh. Wait.
Hold on, Antonio, wait, buddy. You have a question?
No, I cannot do
Okay. So, how about Kathy? How about Kathy?
it.
Kathy's 8, right? How about, what's his name, Paul? How old's Paul? 24. Go back up to the top, write them in. All right? Kathy's 8 is going to write it in. Kathy's 8. Paul is 24.
So then 8 years.
There we go. We're done. It doesn't matter. Guys, I don't think, we're always going to, correct me if I'm wrong, we're always going to ask them to solve for the present, never for the future, right? It's asking their ages now. Antonio, I know where you're going. You could figure out their age in 8 years. How can you do it?
You just add.
Just add it. We have it represented here, right? I can do 24 plus 8 or 8 plus 8. Doesn't matter. But we're never going to ask you to do that. You're only going to have to solve for the present. We're never going to ask you to solve for the future or the past. Okay?
All right, somebody walk me through the first step.
Write down the names.
Write down the names. What are the two names in this problem?
Pete and
Heather
Heather.
and
Pete
Pete.
and Heather. Okay, Antonio, tell me my second step.
A single variable.
Okay, single variable. Somebody give me a variable that would make sense for Pete.
P.
All right, let's use P. And a variable for Heather.
H.
H. All right. Now what do we do?
Yes.
Yeah, we're going to make our first equation. The equation in column 1 uses the letters in column 1. So it's going to have P and H in it. So it says P is 5 times Heather. How would you write that down? Pete is 5 times as old as Heather. Kyle? Yeah. That's it. Pete, I already have is 5 times Heather's age. So there's your first equation. Okay, on the test, that's the first thing I'm going to check. Did you write that down? Okay, if you get that,
You get some points.
that's the first part. Okay, second thing. Somebody tell me, what do we do next? Look at the next sentence. And what does the next sentence say we're doing? Is it a future or a past? So how much in the future? It's a +6. We're talking about in 6 years. Not 6 years ago. In 6 years. Right? So what do I do now? What do I write down? P +6
Take the single variables, yep.
and H +6. The top one is Pete's age in 6 years. The bottom one is Heather's age in 6 years. All right? Next thing. Right, I'm going to get my second equation, and that's something else I'm going to look for on the test, okay, to get credit. In 6 years, he. Who's he? P. How are we representing P? Not P. P was back in equation 1. We're doing equation 2 now. Kyle? Equation 1 uses the letters in column 1. Equation 2, P +6 uses the letters in equation 2, column 2. So he, okay, what's next? Equals. What tells you equals? What phrase? Will be. So he, P, will be. What should come next? 4. Then what? Parentheses. 4 times as old as she. Who's she? Heather. And how are we representing Heather? Not H. +6. Remember, column in the second equation in the second column uses the stuff in the second column. Equation in the first column, stuff in the first column. Good. So if you get that far, you would get half credit. All right. Trenton, can you tell me what I do next? Just tell me the general idea. This is the whole like meat and potatoes of the problem. What are we doing now? Yeah, we're substituting. Now we're actually doing the substitution step. What letter are you going to substitute? P in which equation? The first one or the second one? You're not changing P in the first one. You're changing P. Anyone help Trenton out? We're changing P in the second one. Okay. This is what is going to change. Right? So sometimes what I do, same thing Mr. Roy just did, copy it down, and now rewrite it. What are we going to change P to? Josh? 5H. P equals 5H. Okay, so replace that.
I was going to substitute the row 1 equation into the row 2 equation.
Dominic, how many different letters in that equation? 1, good. Just H's, that's how you know you did it right. You only have 1 letter now. So when we're done solving this, whose age am I going to know? I'm going to know Heather, and then I'll go back and figure out the other person. All right, somebody tell me my first step on the right-hand side. Distribute. What's going to happen on the left? Stays the same. Shannon, can you distribute the 4 and tell me what I get?
4H.
Yep.
Oh, you want me to keep going?
Mhm.
Oh, okay. So this is 24.
Plus 24.
Yeah.
All right. Sabrina, can you tell me my next step?
Minus 4H.
Yeah, try to keep the variables positive by moving the smaller one, like Mr. Roy said. You should never get any negatives here. Okay? Subtract 4H. What's 5h minus 4h? H. Why is it nice when you get just an h? You're not going to have to do the divide step again. That's not always going to happen. Okay, that's what happened on these two. So we get Heather, or h plus 6 equals 24. And my last step, Aiden, to figure out how old Heather is.
You're in a -6 on both sides.
Yep, you're going to minus 6. So how old is Heather? Heather is 18. And once you get the first person's age, the second one is easy. All we got to do is go back up. Which equation would help me get, who was P again? Pete. How can I get Pete's age? Equation 1 or equation 2? Equation 1, right? Pete's age is already by itself. How old is Heather? 18. So 5 times 18 gives me, might need a calculator. Oh, we know it? Yeah, 90. Pete's 90. He's lived a good life.
Pete's dead.
I hope not.
No, you need to.
So now, what else do we have to do? One more thing. We did it on the last problem. What's the very last thing we did? Jordy, what's the last thing we did? I wrote it in. I did it from my mouse on the computer. What's that? Maggie?
That's their names, right?
Yeah.
They're gonna spot there,
So make sure if there's a blank on the test that says Pete, and then a blank.
There's a blank on your notes though, guys.
Yeah, fill it in on the blank on your notes. Pete, put
P
90.
equals 90 and Heather equals 18.
Heather equals 18. Okay, any questions on that one? Aiden, what's up? Do you have a question?
Hey, and I have a question for you. Why don't you have that example right now?
Okay, guys.
What's up?
I'm gonna make you all come in on the snow day. All right, what's different about this one? Jordy,
Yeah.
what's different about this problem?
They both have different names.
Well, they've all had different names in every problem. Read the problem, something different than the last two.
Oh,
Somebody said it.
What? Say it again.
oh, write the names in, right?
Well, I'm going to do that in a second. I'm just asking what's different. Mr. Rice said you could have two kinds of
It
problems.
goes back.
10 years ago, so this is a past problem.
Back in time.
This is not on the,
It's the second, it's the second one. It's really small, right? The second one. Look at the name on the side.
All right, let's do this one.
We'll go back to, so guys, don't worry about writing it down, all right? Not worry about writing it down, but where it says extra example 1 on your sheet, let's do this one together.
Still, is this the same kind of problem? Is this a past problem? Well, your choices, it's either going to be future or past. It's one of the two. What tells you it's in the past? Ago. 12 years ago.
Guys, this is your example 3.
All right. Emma, can you tell me first thing I do? Put the names. So Leah and Walt. Okay. How about Ashley? After I put their names, what do I do? Single variable. What do you want to use for Leah? Okay. The only thing I'm going to do is I'm going to put a capital L, so it doesn't look like a 1. Antonio, what next?
You put the W on the letter wall.
Yep. So W for Walt. Now my equation. Who can set up that first equation for me?
L.
Josh? What is it?
Oh, no, I'm sorry.
L equals, yeah. Leah is 8 years younger than Walt. It's important you put the person's name first, the letter minus the number, not the other way around. Right, so there's our first thing. Now the next thing we already figured out. This problem was about the past. How many years in the past? 12. 12 years ago. So what does that mean you're going to do? What operation? Subtract how much? 12. So, Marissa, what would be Leah's age 12 years ago?
How'd you represent?
Yep, L minus 12.
Don't get wrapped up in how to put a number, guys. It's that simple. Don't overthink it.
How about Walt's age 12 years ago? W minus 12. And now, to make our second equation, where is the stuff going to come from to make the second equation? It's going to come from the second sentence, and how are we going to represent the names in the second sentence? L's and W's, or L minus 12s and W minus 12s?
Excuse me, it might have like, oh my god, I might so much. Okay, but
So yeah, we're going to use the L minus 12s and the W minus 12s. Stuff in the second column. So 12 years ago, Walt was twice as old as Leah was. Can somebody start off that equation for me? Josh? 12 years ago, what comes first? Walt. Walt is the first thing in that second sentence. Walt was. It doesn't say Leah was. It says Walt was. So how do we represent Walt? Nope.
Walt, 12 years ago.
Remember, L's and W's don't exist anymore. You're not using single L's and W's. That was the first equation. You've got to use the L minus 12s and W minus 12s. Yep, Eastleys? Yep, W minus 12. Walt was. Hannah, how would you do was? Was is, it's like the past tense of is. Equals. Okay, was, is, will be, they mean the same thing. So Walt was twice as old as Leah. Now we're going to use Leah. Twice as old as Leah. How would we write that? Yep.
Select the 2 and then you put in parentheses L minus 12.
Perfect. Twice as old as Leah. Okay, and there's our second equation. What are we going to change in that second equation? What letter are we going to plug in for?
L.
L. And what are you going to plug in for it? Yeah, we're going to fill in W minus 8. Okay, so can somebody give me that new equation, just plugging in what I just did for L? How's it going to look? Ashley? So you're on the right track. You're doing good. So what do you want to do next? 12. 12 outside the parenthesis? No, not outside. You want to keep it exactly the way it is right there. The only thing that changes is what's circled. So the minus 12 is going to stay right where it is. And that's it. Now, before we do distributive, right, PEMDAS, we've got some stuff in the parentheses first. What can I simplify in the parentheses? Emma?
You have to define like term,
Mm-hmm.
so -8.
-8. Does it take away something? What do I simplify? Well, what are your like terms? The numbers. So what do you get when you combine them? Someone help Emma out. What's -8 take away 12? Not -4. That'd be 8 take away 12. It's -8 take away 12. -20. Okay. Now that we've combined those like terms, what can we do now? Yeah, now we can distribute it. Okay. Vanessa, what do I get when I distribute?
2W
Yep.
and -40.
Yep. -40. All right. Which variable should I move, the W or the 2W? You can do it either way, but one way is going to be a little easier. W. How would you move that one?
Subtract W.
Good, I like it. Subtract W. What's 2W take away W? Oh, 80? What's 2W take away 1W? Yep. Just W. Now, I've got some negative numbers there, but hopefully they disappear, okay, because I should not get negative age. So what's my last step? Okay. Yeah, we're going to add 40. Add 40. And what's -12 plus 40? Okay? 28. Okay, and who was W again? That was Walt. Walt? All right.
Why did they not name him Walter? I really know Walter.
All right, so how about Kaylee? What do I have to do next?
Wait, go down.
So what else do we have to? We have to still find what? Yeah, we still got to find Leah's age. But now that we know Walt's age, that's easy. So to find L, Maggie, which equation should I use? 1 or 2? 1? You sure? Yes, you are right. You're going to use equation 1 because L is by itself. So Leah equals, how old was Walt? 28? -8? So how old is Leah? 20. And that's Leah's age. Okay, so these kinds of problems, if you just try to think it through and try to guess the answer, it can be a little tricky, but if you set up these equations, it takes the riddle out of the problem. It's not hard when you use algebra to figure it out. Okay, so couple reminders before we let you guys practice another one on your own. Okay, the homework tonight will be a worksheet. Okay, that'll be due most likely Wednesday, the next time we have class. Okay. On Wednesday, we're going to review age word problems.
just like we did today.
Test on Thursday, because Friday is a half day.
Oh, wait, yeah,